And bonjour, this is Bruno LARVOL from the LARVOL Group, and you're listening to a weekly podcast, which we call Building in Public, because we share with you the steps, the challenges, the successes of us building our flagship product, which is called LARVOL CLIN. Today, Daniel Jaramillo is joining me, and we're going to talk about a very ambitious aspect of our work that has to do with AI, obviously, but in particular benchmarking and evaluation of AI models based on our data set based on cancer data. So Daniel, welcome as a frequent flyer and recurrent guest on the podcast. Welcome to the podcast.
Hello. We're going to talk about data today. I like it.
So I'm going to let you go and interrupt you only if I need to, because I have something to say or because I need to say something. So please go ahead. Tell us what we're doing with benchmark and evaluation, and also why we're doing it.
Okay, so we all know it. It's the AI era. Everything has to do with AI. We're trying to integrate it into as many things as we can. We are pioneers and leaders on applying AI into oncology data solutions for any of our clients or potential clients or you who's listening. And as part of that effort, we needed to understand what the best, which of the foundation models, we're going to start with the foundation models, is best for handling different types of oncology data. So we decided to start doing benchmarks and seeing which are the best for what. So it's a bit of a pilot that we're running. We're trying to post one benchmark every week. And so far we've done a couple. So we have tested for approvals. So any drugs that have been approved by FDA. And basically the way it works is we get about 100 questions. So 100 drugs that either have or haven't been approved. And we know the correct answer. And then we will prompt all of these models with that. Right, we'll ask them, has this drug been approved for use with this patient population? And then the AI will respond to us, and then we can use certain grading techniques so we can take out any false positives, what the accuracy is. We're still working on prompt sensitivity because if you're versed with AI, you'll understand what I'm saying. If you're not, it's basically the way we ask the question might influence the answer. So we're still, it's a work in progress in many senses. We try and evolve it every single week that we publish a new one, but these latest results that we have from the last two that we've published, we have used what we consider as pretty good formulas to calculate and basically whip out accuracy out of the question, false positives, false negatives. We take into account all of that. So if you were wondering, if you want to talk about approvals or ask an AI about approvals by the FDA, specifically for oncology products, you should go to Grok or ChatGPT because they're very good at knowing what is and isn't approved, and they will give you a quite correct answer. Now, if you're using Gemini, hopefully, fingers crossed, you are not treating anyone. I mean, to each their own, but I wouldn't.
If you have to pick an oncologist, Dr. Gemini is not the one to pick, at least according to that very specific panel of tests. It's not doing very, very well. It's wrong, I guess, 60% of the cases.
You're better off guessing, is what we're trying to say. If you want to know if a drug has been approved and you're locked in a room and the only thing that you have is Gemini, if you guess, you'll have a higher chance of getting it right.
So because these accuracy numbers are not adjusted per the possibility that the model would just be guessing. So in other words, if the model were to guess that 50-50 chance on the idea that our test set has 50% true statement, 50% false statement, then it would get, in theory, it should be penalized and get zero. But in this case, it would get 50%. Is that right? These are unadjusted, right?
These are unadjusted.
So it takes talent for Gemini to do worse than a dice.
Well, I like to think from foundational AI models as toddlers that have read a lot of books, but they don't know what to do with all that knowledge.
Gemini
I
didn't
think
read the books.
Gemini. I
You
think
missed that
Gemini
book.
licked all of the books
It,
all over.
it drawled on the books. It
And now
made
this
confetti out
hurts
of the
for me
book.
to say because I love Gemini. I've been using it more than
Yeah,
ChatGPT
and
lately.
to our friends at
Um,
Gemini, we love you. This is only one test, and no, our testing methodology is still being refined. I think actually in some of the other panels that we're going to publish later on, Gemini is doing very well.
well,
So it might be an
let me just
anomaly.
let me just concur our MC and let's go to image number 2 because our natural progression from drug approvals was black box warnings, right? Because ideally, if you are either a patient advocate, an oncologist, or somebody that's researching, you want to know if whatever regimen you're putting the patient on or regimen you're researching is going to give the patient a case of sudden death or diarrhea or something that's been put on a black box warning by the FDA. So if we move to the next benchmark that we have, we ran a black box warning benchmark in which we asked if 50 drugs had a black box warning, 50 drugs didn't have a black box warning. So we asked the AI, does this drug have a black box warning issued? And the results are a little bit different, which is surprising because they're issued by the same institution, right? So FDA does approvals and they also do black box warnings. But some models, for instance, Gemini, don't know what's approved, but they're quite okay of knowing if there's a black box warning for it. The one we're working on right now actually is asking it whether the black box warning has a specific condition or side effect, right? So we're going to try and test the accuracy of how well these models that we added, and we actually added a couple more on the latest version that we'll publish next week.
So Dr. Grok, as opposed to Dr. Gemini, so Dr. Grok is pretty good at knowing what a drug in cancer is approved for and whether or not it has serious adverse events, adverse effect, side effect. That's what's called a black box. That's not good to have a black box if you are a medication. But Dr. Gemini somehow it's very good at knowing the side effect of these drugs, serious side effects, but doesn't know which cancer they're approved for. Now, the reason for that discrepancy is not clear.
If we go back to the licking books metaphor, if it licked the drugs, it probably knows all the side effects.
It's a licking problem. Yeah. I see.
We'll see. The two things that we've seen consistently is, and hurts to say it because I know they have a lot of fanboys, Claude, right? The models by Perplexity. We're not there yet.
Yeah, Claude is behind on a bit.
We're not there yet. There's a reason actually. So these all were done in the last couple of weeks. So we know that Claude 3.7 Sonnet is out. The reason we don't use Claude 3.7 Sonnet is if we use it, the response rate, like the accuracy rate for this will be under 10%. So it does its best to get everything wrong. 3.7. 3.5 is decent. 3.7.
Now, how much of that could be explained by the fact that these two test sets are factual? These are ground truth in the field of cancer. So this is a factual test. It's not a reasoning test at all. So by nature, the models that have been grown to be great at reasoning are probably suboptimal for fact.
I think there's also a secondary variable in there, which is 3.5 or any model by Perplexity up to now. We don't know, or we don't think, to be fair, from all of our tests so far, that it can search the web, whereas all the other ones do. Even if you don't turn on the search function, they'll still consult the web. They know how to research and then come up to their own conclusion. So that might be why Sonnet just decides, you know what, I'm going to give everything wrong, because Mistral can search the web, Llama can search the web, Quen, Gemini, Grok, and ChatGPT can search the web. Claude can't, or at least if it does, it still can't. It's not very good at it. So this is the kind of trend we've been seeing with the Perplexity model. And then the Mistral one is also very hit or miss. Now, these two also have an important consideration, which is if you are active on any forums or social media, i.e. X or Reddit, you'll see that these two models are largely have been more adopted by the programming community as co-pilots. So maybe their reasoning has expanded on logical thinking and helping out with programming or building little apps, whereas the other ones are more of like general intelligence models with a lot more vast knowledge of everything else. Um, and I think this is a nice little segue, so we can go to the next screen, and we can see kind of what the methodology we use is, right? So we'll spend quite a good amount of time designing our prompts. So those are the statements that we have over there, and these are some of the tables that we use internally to consult. And you can see the raw results on the right, of the true positives, true negatives, false positives, false negatives. And we use all these metrics to calculate accuracy, precision, the recall or sensitivity, which is how much it fares with accuracy and precision. It's a measure that combines both. And then an F1 score, which combines everything, right? So it takes the true score, the accuracy, the precision, and the recall, and it gives us an adjusted score that accounts for it kind of guessing, or if it tends to get the false negatives right, but the false positives wrong, it'll adjust for that. But we can see we adjust our prompt a lot. We go through many iterations of our prompt. We see which prompt does best with the majority of models so that we don't have prompts that preference one model to the other. We do not change prompts between models. So it's not like we're going to have a ChatGPT 4.0 specific prompt and then one for Grok. I know that a lot of people agree that there is a best practice for prompting each model, but we try and keep it as straightforward as we can, right? So we find something that works generally best for all of them, and we'll use that for benchmarking. We keep the format exactly the same. The only thing that will change is the variables that we have. So say if we're talking about black box warnings, it'll be the drug name. If we're talking about black box, checking if a black box has a certain toxicity or secondary effect, we'll have two variables. We have the drug name and the effect. And those are the only two things that change in the entire prompt. And then we can test a lot of things. We've done many other tests internally, so we've added kind of a level of certainty to the answer. So we've prompted it and we've said, not only say yes or no if you think this is correct or incorrect, but only answer if you're 80% certain that your answer is indeed the right answer. And if you're not 80% certain of any of them, just say uncertain. While we figure out a way to accommodate mathematically for that on our scoring, we will keep it out. But we've seen very polarizing results when you add that level of certainty to the answer, right? It'll flip some of the models that do great without it, do really bad with it, and vice versa. It's very interesting, the amount of information you can learn by just running these types of prompts. And in the future, we hope to expand not only the size of our samples, because we do have a lot of information that we can use to benchmark these AI models, a lot of information, but also the complexity of our testing, right? So we can accommodate for prompt sensitivity, we can accommodate for the confidence scoring, we can accommodate for if we run it multiple times, how many times it changes its mind while answering, right? Because the same model might give you 3 different answers for the same question if you prompt it 3 times. So there's still a lot of room to grow, but we're very confident that this is an interesting effort for all of the oncology community and all of our internal efforts applying AI.
Thank you, Daniel. So LARVOL CLIN is what we believe is the most curated ground truth database in cancer to be used for AI. And we use it, of course. One of the use that we have is benchmarking and evaluation of existing models, frontier models in particular, potentially fine-tuned models. Although we haven't applied it to specialty vertical models,
Not yet.
BioBERT and so on yet. Okay.
Hopefully coming soon. We have a lot of open source models based on top of Llama that have done really well in other general medicine benchmarks that we want to test for oncology specifically. Because if we find any of these specific models that does fantastic, then we'll for sure have a benchmark out for it, and then we might include it in a lot of our pipelines to get conclusions and analytics a lot faster than we do right now, which would be hard because we're very fast.
Daniel, thank you very, very much. And for the audience, if you're interested in what we do with LARVOL CLIN, if you're interested also in our benchmarking effort, if you have your own model, you'd like to make sure that we include your model in our benchmark, please leave a message on social media or connect with us. We always appreciate it. Thank you very much, and we'll see you next week.